But how do I calculate inductance? Okay, number one, use equation and the methodology that you're going to follow will be number one, find the B field of the current carrying wire inductor, current carrying inductor. Step two, calculate flux, phi B. And number three, use Flux law to find induced EMF due to the changing current. Okay, once we know these steps, I can use them. Okay, suppose current in an inductor sets up a B field that we can easily calculate by knowing one, the size and shape of the inductor, and two, by knowing the distribution of current. So once that is done, this will give us the flux phi B through each turn of the coil and if I suppose flux always has the same value for each of the N turns, may I write total flux as N phi? Right? That's very obvious. Now, textbooks define this as, they have a word for it, and they call it the number of flux linkages of the inductor. So all what books are talking about when they talk about flux linkages is take your magnetic field, multiply it with the number of turns. That's it. They just have given it a fancy name. So then so once we have the phi b or flux calculated, the next is to use the flux law to find the induced EMF due to the changing current. Okay, so then I can do EMF from flux rule gives me EL equals minus d phi over dt or minus dn phi b over dt. And I know this side was L di over dt. And this side is minus d over dt of n phi b. I can integrate with respect to time with the boundary condition that when I equals 0, phi b equals 0. That's a reasonable assumption, right? When there's no current, there's no flux. There's no B field. So what will I get? Or put this in a box and call it something. That's an important equation. Oh, this should be I. My bad.